Hello. In this video, I want to give some more details about Code Critic, which I could not include in the blog post and also in the README file of the GitHub repository. So when we have the submission in the form of a single program file, this is what the pipeline looks like. We start off with a detailed problem statement, a rubric, and the program submission, and then we pass it on to an LLM to obtain an initial draft of the feedback in a particular structured format. And then we ask the LLM to reflect upon it and to revise it, refine it, check it for accuracy. And once we have that, then we take the structured output, which is basically the list of all the comments to be inserted in the program as feedback. And we take the original program file and we sort of merge them together to get the final output. Now, uh, for the original program which we have, we first pre-process it because what we want the LLM to do is to give feedback for particular line numbers in the program. And it's helpful if we can prepend each line with the line number. So for instance, here is what the pre-processed submission file looks like. So each line has the line number initially. The plus sign here means that these are the lines which are added. So for a single file submission, it's basically all the lines in the file. And once we have that, then the proposed LLM gives its output in a structured format, which looks something like this. So it's basically a dictionary containing two fields. The first is annotations, which is basically the list of all the comments to be inserted in the program. So this is the first draft of that. And then the second field is summary. And summary talks about the strengths, the areas for improvement, and so on. Now the annotations, each in this list, each element is a dictionary. And here the most important fields for us are the line number and what the actual comment is. The summary is useful because sometimes some of the issues which may be highlighted, those are global issues, and it's not often feasible to give individual comments for that, and so on. Now, once we have this, well, I would also like to point that there's a benefit to structured output. First is that it makes it much easier for us to sort of parse the content. Otherwise, we would have to write our own parser for what this LLM gives us. And also, this makes the output of the proposed LLM more compact. Once we have that, we ask the reviewer LLM to take this, and we also ask it to integrate the output of a linter to give us the final annotations. Now the linter output looks something like this. So because in this case I was working with C programs, I ran the client ID linter. Now there's quite a lot of material in this linter output, and it's not the best format to give to the reviewer LLM because it's sort of polluted with a lot of path names, and in fact these individual issues, they are oftentimes repeated again and again. So for something cleaner, we ask an LLM to summarize the essential points of the linter output, remove the path names and so on. And we give this as input to the reviewer LLM. And we also give these original ones, the problem statement, rubric, and program submission as well. So in the context of these, we ask the reviewer to integrate the linter output and refine the output obtained by the proposed LLM. And finally, we get a structured output object, which is exactly similar in format to this. Once we have this, then we take the original program and then we kind of make use of these line numbers to decide where to place this comment, and so on. So the final output looks something like this. The only thing to keep in mind is that when we take these comments, it's like a long string and it has to be formatted properly so that it doesn't just like uh, take up one huge line. So we make use of the text wrap module in Python to format these comments properly before inserting them. Now, if you're running this program for a large batch of submissions, we have to be a bit mindful about the API cost. And we can save a lot on API cost by means of prompt caching. So what prompt caching means is, let's say we make an API call and we give a prompt to an LLM. And this is what the prompt looks like. Now the next prompt, if it's by and large similar to this original prompt, then these tokens which are similar to the first prompt, they are by and large they are not they don't cost us. So we only pay for, or we don't pay much for the cache hit tokens, and by and large we pay only for those tokens which are new in the new prompt. And if the second prompt looks very different from the original prompt, we by and large have a cache miss, and so we don't benefit from prompt caching, so we end up paying a bit more. Now, in this case, if we look at our architecture, we see that both there's a lot of redundancy here, or rather a lot of similarity in the prompt which goes to the proposer LLM and to the reviewer LLM, because both of them, they take these elements, they are common to both of these LLMs. But to be able to take advantage of this prompt caching, we have to be a bit careful. And so what we do is we first run the linter, first of all, and then we run the proposer and then the reviewer, and so on. So we have to be mindful that we don't run first the proposer and then the linter, because then we will have a lot of cache miss and we won't benefit from prompt caching. Now, for the case of repo submission, the idea is that students start off from a base repository and build functionality on top of that. And ideally, we want to provide feedback only on the parts which have been added to the source code base. And to be able to find that, we can make use of the diff tool. So in my case, when I ran diff for my own source repository and target repositories, which are given in input examples, we get an output of this format. And here, by and large, the content of this diff is for those files which have, let me scroll to somewhere interesting. Yeah. So here there was a file in the source repository called proc.c, and the student added a few lines, or actually quite a bit of lines, to this code. So the diff tool tells us which all lines have been added. And the second type of output which the diff tool tells us about is which are the files which have been newly added to the target repository. So for instance, in this case, there was most of the new implementation is in this file called thread.c. So what we do for our own case is by means of Unidiff module in Python, we easily run through this diff output. So we loop through all these different elements which are delineated by at symbol, and we check if they actually correspond to .c files, because we are mostly interested, most of the interesting implementations, they happen in our case in .c rather than .h and other files. So we check if it's .c file, then we consider it for feedback. And then we also check which are, so we parse this output and check if there are files which are only there in the target repository, and if there are .c files, then we consider them, those are sort of the newly added files in the target repository which were not present in the source repository, and we consider that as well. Now with all these list of files, in essence what we do is the pipeline which we had for single file submission, we in a way we run it in a loop for all these different files. So the problem statement and the rubric, they remain the same. In each loop, it's the program which is different, the program file. So let me show you, when we pre-process the input program file, in this case, what does it look like? So as we mentioned, proc.c was there in the original source repository, but some lines were added. And to tell our tool that these are the lines which were implemented by the student, and to give feedback on these lines rather than give feedback in general about the repository, we mark them by these plus symbols. So we do this, but we make sure that we don't just give as input to the tool only these lines marked by plus, because in a way that doesn't give much context. So for instance, it would be just like come out of nowhere if we gave only these lines. We could have parsed the whole function, but I felt it was better to consider the whole input file and just mark those lines which have been newly added. And for those files which have been completely newly added, it very much resembles this pipeline, the whole, it resembles the one which we saw earlier for single file submission. And by and large, it remains same. I would only like to add that in my example, in my use case, I didn't use linter for my own assignment because the assignment was based on the x86 repository, and linter is not very well suited for that case, but it's very easy to include it in the pipeline as well. Now, the kind of feedback which we want in this case is basically it's best. So it's best if we have just a single file for the whole repository where we provide feedback for each of the either the modified or the added files, and we sort of concatenate these together. So we first say that for what file is the feedback there, and then what is the list of feedback. And when we are giving the comment, then just below that we also tell what line number does it hold for, and also we present the code for that line. So you see, like for this assignment, the student did some modifications to a handful of 3 or 4 files, and it was, let's see, yes, so we do see that proc.c and thread test. So in fact, thread test was the file where most of the implementation was done, and some of the additions were also done in proc.c. I decided not to put the summary at the end of this feedback, because I felt like the different feedbacks in different places, they were sort of disparate. But if you want, you can do it otherwise, and it's very easy to include that. So that's all. Thank you.